Alright, good evening and welcome to today's class. We continue from where we stopped, which is properties of quadrilaterals. We have discussed two of them already in our previous class, which is, I guess, kite and a rectangle. And when we say property, it means certain factors that a particular thing is being identified with. What differentiates something from another one? All right. So these are meant by properties of quadrilaterals. They may have similar, but they are not the same properties. So let's actually go through it today. And please try and go back to the previous lesson so you can connect the previous with the present. That will really be of a good help to you. We're going to take another two today, just bit by bit, all right, so that it sinks into us. Um, the first today is square. Square. We behind the word square. So thing has a square shape. The other thing has a square shape. Now, in the real sense of it, what are the things that squares are known with? What and what are the properties of a square? What and what can one use to identify a square as a shape? All right. So let's actually look at them. Now, number one, we say all four sides are equal. This is a square. It has four sides: one, two, three, four. The four sides are equal. Hence, this stroke we are saying here now, right? One stroke, another one. Mean that all the four sides are equal. Number two, all angles are 90 degrees. All the angles formed at the edge here are 90 degrees. All right. This is okay. Okay, this is a diagonal. This line here, this broken line. Likewise, this. Each of them form at least two right angles, which are these ones you are seeing at the edge of the square. All right. So all angles in a square are 90 degrees, which is right angle, are 90 degrees. Three properties say opposite sides are parallel. Opposite side here is opposite to this place. Likewise here and here. In other words, here is parallel to here. Likewise here is parallel to this side. Is that okay? Now the fourth one says the diagonals are equal. This diagonal, the line that runs from one vertex to another end, this is diagonal, another diagonal, from one edge to another edge. All right. So they say the two diagonals are equal. Now the fifth property says the diagonals bisect each other at right angle. Like I said earlier, these are right angle. Okay, pardon me please. They bisect each other. This is one, this is another one. Now, these are points of bisection. All right. Now here says they bisect each other at right angle. It simply means that at this particular point, okay, now this point where they both bisect is at right angle with another. This is a straight line. All right. Now this one is moving from this place now. This point you are seeing here now, a right angle is formed here. Another one is formed here. So the place of bisection, a right angle or right angles are formed. So here it said the diagonals bisect each other at right angles. This is one diagonal. Another one start from here. The point where they meet, all right, is the point of bisection. At this point, an angle is here, the angle is here, and they are right angles. Okay, let's continue. The diagonal bisect the angles. These are the angles. So diagonal bisects the angle. This is an angle. diagonal come to bisect. This come to bisect, likewise here and here. All right. Now, the eighth one says it is both a rectangle and a rhombus. Yeah, this might actually sound somehow. A square is actually a combination somehow of a rectangle and also a rhombus. Now, I'll leave you at this because this actually need you to crack your brain. At least you know what rectangle is. Now get a rhombus. Now see how this and this will give a square. That will be an assignment anyways. But I'm going to state it that you all can actually attend to it, which is explain how a rectangle and a rhombus gives a square. Exactly. Let's continue. The fourth one says, sorry, the second, what's it called? Quadrilateral, which is parallelogram. Parallelogram. This is the shape. This is how it looks like. All right. First thing, you know that opposite sides are equal and parallel. Here and here are opposite sides. Likewise, here and here are opposite sides. Here, and here said here and here, which are opposite, they are equal and they are parallel. They are equal and they are parallel. Likewise, here and here, they are equal and parallel. All right, good. Let's continue. Opposite angles are equal. This is opposite angle. This and this are opposites. Likewise, this and this are opposites. All right. Now, angle here and angle here are equal. The one here and the one here are also equal. In case when you are being asked, maybe you are given angle to work on in parallelogram, you should know that if here is 80 degrees, here is likewise 80 degrees. All right. Yes, the adjacent angles are supplementary. Now the angle here, the one from here to this line of bisection or diagonal, all right? Then from here to here, these are angles in this triangle here. And here said they are supplementary, mean that their sum is equal to 180. And this is a proof that sum of angles, or rather, this validates the proof that sum of angles of a triangle is equal to 180 degrees. An angle is here, another one is here, that one is here, inside this triangle. So they are all supplementary, meaning that their sum is equal to 180 degrees. Okay, let's continue. The fourth one say the diagonals bisect each other. You can see this diagonal, that diagonal, and they bisect each other. Okay, opposite sides are equal in length, like we said before. Opposite sides are equal in length. Here and here are equal. Here and here are likewise equal in length. So that is just properties of a square and a parallelogram as quadrilaterals. Alright, so kindly go through the video, play it one over until you're able to memorize all of them. Thank you for being part of today's class. See you. Bye.